I'm CK. Tonight we're going to do what I hope will be a fun one. It's from our friends at Befaco, and it is their Crush Delay unit. And knowing Befaco, it's probably more than a delay unit. It's probably got some interesting features and functionality along the way. So a good delay is always good to have. So we'll put it together, see how it sounds. Hope you enjoy the video. Here's the bag from Befaco out of Barcelona. It's a big bag and it's heavy too, heavier than most. I don't know what all we have in here. Circuit board and PCB. Let's take a look at that first. Interesting. Oh, I see. I was about to say it's interesting that they put circuit board in an ESD safe bag, but it's because the PCB has some surface mount components already on it. The 3 ICs, which are LM3700s, and 1 transistor or voltage regulator, I'm not sure what. And as you can see, excuse me, the sprues are still on the boards holding the circuit boards together. I will bust them off in a little bit. But first, let's take a look at the front panel. Got potentiometer here for fast, clean, slow crush, feedback, dry, wet, time. It's 10. These look like 10 volt ins and outs for volume. I'm not sure what all these are. I don't know if they're jacks or. Let's take a look. Okay, so pot, jack, 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 a switch. Oh, actually there's 1, 2, 3 switches, and then 2 more pots and some more jacks. Don't know what all these switches are going to be. That's kind of interesting. And the board is a typical good quality board from Befaco. None of the values are on the board, unfortunately, but part of the reason for that is Befaco packs their boards so full they don't really have space for it. And as usual, in a Befaco circuit board, if you look here, these meandering circuit traces. I mean, this is like a delta with many little tributaries leading into it. I'm just always amazed at how curvy and swoopy and non-straight Befaco's circuit traces are. I don't see anyone else who does that. So that's circuit board, and of course it's all through-hole plated. And I'm probably going to break these apart off camera because I will be taking some sandpaper and sanding off the rough edges that the sprues leave on. Oh, that's also interesting. This comes in, and then there's an indent, and then don't know why they did that either. Looks like the typical Befaco build guide, which is pretty simple, but you always want to glance through it and see if there's anything that they highlight that you want to do differently. A bunch of ICs in there. I'm not going to open that up yet. Front panel knobs, they're plastic. No metal inserts. Did give us some knurlies to put it on the board on the in the rack with, which is good. I like knurlies. A nice power cable. Whole bag of resistors and diodes. Diode time is, resistor time is going to be pretty long this evening. Also, there are 2 ferrite beads. Befaco often uses them. They're usually by the power connector. Let me try and find them. Yeah, the ferrites go here and here as we come off power to get rid of some high frequency or radio interference noise. 6 diodes. Oh, and Zener in there. So with the ferrites, we have to remember to save some resistor leads to use to mount the ferrites. Then we've got a bunch of resistors, 1, 2, 3, 4 trimmers, a bunch of 104 buffering caps is what I call them, a couple of electrolytics, switches and pots, power connector, a couple of standoffs, and all our jacks with the very attractive burgundy panel nuts that Befaco includes, and of course yet another Befaco panel nut wrench. I've got like 6 more of these, including this one. So that's what's in the bag. Looks kind of fun. Looks like with the resistors in particular, it's going to take a little bit of time to get this thing put together. But I'm going to get the soldering iron heated up and we'll dive into it. So as I said, I broke the circuit boards apart off camera and sanded the rough edges down a little bit. And now we're going to dive into this. Here's bag A. Here's my resistor bag. The only thing you want to be very careful with is you want to make sure you don't lose the ferrite beads, because they can get wrapped around things or get trapped in stuff. So I'm going to pick them up and put them back in this little bag so we don't lose them. And the first step to get us all excited is 20 100k ohm resistors. That's resistor time for this build. Whole bunch of resistors all over the place. And as you can see, I checked them all off as I did them. Always do that. Don't make life hard on yourself trying to remember things. Just check them off. Next thing we'll be doing is diode time, and we got a bunch of different diodes. That's interesting. We've got the standard 4148s, then we've got 4.7 volts, 2 2.4 volts, and 2 3 volts, as well as the standard 5817s. So that's interesting. Yeah, these are marked 4V7. Okay, so these are the 4148s, I'm pretty sure. I'm having to flip my magnifiers up and down. Yeah, these are the 4148s, and these are the 4.7. Now let's look at these two, 2.4 or 3 volts. Okay, these are 2.4s, so that's good. And that, by process of elimination, means these are the 3s. And I'll go ahead and turn the, go into fast replay again. Okay, that's the diodes. Now you may have noticed, unless I cut it out in editing, the 4148s, the first 4, were kind of hard to find. They ended up being here, here, and here, and here. The first 2, D1 and D2, really hard to tell because they didn't use the standard diode symbology. In other words, there's not a triangle with a bar. It was simply a little box with a slightly heavier band to show where the stripe on the diode went. Really hard to find. I had to go back to the drawing to try and isolate it and find it. Okay, next thing we'll do is we'll go back to our little bag and get the ferrite beads out, and we'll make those up. And the ferrites go, should go near where the power is. So that's typically what you use ferrites for, and they're here and here. Ferrites do a little filtering on the power. So I'll dump the ferrite beads out again, and there's both of them. And I'll grab one of the resistor leads we saved when we're in resistor time, slide it on, and just fold the wire over. Doesn't matter how long, as long as it goes through the circuit board and you can solder it. Put that one in there. I'm going to solder this immediately, because if that were to drop on the ground, I would never, ever, ever find it. Okay, now we get the next bag. We get the IC bag, because we're going to put all the sockets on. So instead of trying to open the bag like a normal person, I just cut it open. I'm going to put all the sockets on the boards. And as we do this, again, the way I like to put sockets on the boards, and I guess they all go on the other board. That makes sense. As I like to do sockets, I, of course, make sure that the notch and the notch are going the right way. And I will set it in like that. And I'll flip it over, flip the board over, support it, and support the socket with fingers behind the board. And then I will make sure I have the right socket, because that's not the right socket. That's the right socket. Support it with my fingers on one side of the board, solder one leg down, let it cool, and take a look. Make sure it's all flat, perpendicular, all the pins are aligned, and then it's not going anywhere and you can move on. And that's all the sockets on the board. What's next? Now we're going to do a whole bunch of capacitors. We've got some electrolytics, we've got some foils. I'm going to move these trimmers over here with the transistors. And then we've got a whole bunch of what I call buffer caps, these 100 nanofarads, these 104s, these 1/10 of a microfarad, which are ubiquitous in the PCB, in the PC board realm. They're generally put, if you're ever looking for where they are, these little 104s generally go close to a socket or close to an IC, as close as possible. They are to provide a little voltage buffering to the current flow and voltage flow, so that the chip never sees low voltage or high voltage. The IC will take care of that. I mean, the capacitor will take care of that and smooth out the voltage from any little fluxes. Now we'll just find them all, and there's a bunch of them. And again, look near your circuit your ICs, and that includes the surface mount ones that we didn't install but came pre-installed. And yes, I am going to cross each one off because I get confused if I don't. Now we'll do the electrolytics, and a Befaco board is pretty good at indicating polarity. They have plus signs and minus signs at the appropriate pinholes, and they have a little white stripe by the negative pinhole to go with the stripe on the electrolytics. In fact, see this, around the positive side they have just a bracket, kind of an open line, and around the negative side they have a solid line. So let's see, 10 microfarad, it's these, three of them. Now the other thing, and I've seen this on other Befaco boards, the two holes for the cap are much narrower than the splayed legs as they come off the cardboard. So what I do is I take a pair of needle nose pliers and I straighten the legs, taking that little bend out of them, roughly like so, and that way they will go in the holes flush to the surface of the board, like that. If you don't do that, then you're going to be fighting with it and then you're going to be grumpy. So I'll continue to do these and we'll put that in fast motion playback. And that's all the capacitors on the board, and it looks like they included a spare 47 microfarad. Now we'll do the transistors, and we'll do the 3904s first. There's 4 of them. And then we'll do the 3906s, and they go, where do they go? They go here and here, here, and then on the other board. And nothing much to say about transistors, particularly on a Befaco board. And now the 4 trimmers. They are all the same value. They're all 100K, which is nice. And let's see where they go. I think they all go on this board. Go here, offset 1, offset 2, offset 3, and offset 4, and the screws face outwards. There's a little hole there. I don't know why they... oh, it's a test point. If you can see, I'm talking about right here, there are 1, 2, 3, 4 holes that look like they might be associated with the trimmers, but they're not. If you look on the back, that's test point 3, test point 4, test point 1, test point 2. So we don't care about them. We're just putting, at this point, during assembly, they don't matter. And now, oh, we got to put the pin headers on. I didn't even see there were pin headers. I should have known there were pin headers. since there are two boards, but I didn't pay attention to it. So we'll dump these out. Contents of bag C. And find the pin headers. There's the male and female pin header. Now the power connector, which goes where? It goes over here somewhere. Let me take a look at this real quickly. So as you can see, the way this goes together, this board is shorter, as we saw earlier, and it's got that little swoop cut out of it that we noticed before, and that's to allow for the power connector to go in like so. Now we're going to do all the front panel components. We're still not putting the ICs on yet, because that's going to be the last thing. Wait, where does he say to put the ICs on? Oh, okay. He put the ICs in way back when. I forgot. It's been a day since I did that. I chose not to do that because I didn't want the ICs in while we were continuing to solder components on the board. Now we will. We've got TL072s, which are op amps, 5 of them, TL074, another op amp, 4053, and which I don't know what that is, and a PT2399, which is a processor. So I'll put all these in. So the 4053 is a mux demuxer, and let's see what the PT2399 is. PT23, it's an Echo audio processor IC. Huh, interesting. So the PT2399 is the beginning of the delay process by introducing a good audio echo. That's nice to know. I may want to buy that chip in the future. Now we're going to put the spacers on. Secure the spacers onto the control PCB. Okay. So this is the control PCB, of course. So I got 3 of the spacers on, and I keep having trouble with this one nut, and I finally looked at it more closely. The nut ain't got no threads. It's a non-threaded nut. That's unusual to find. Let me see if I've got... This is my box of metric nuts, which I don't use that often. So some of them are still unopened. So let me see if this is the right size. I think this is the right size. Yep, that's the right size. So go ahead, send me blank nuts. I can recover. I have the tools, I have the parts. Always, always, always when you take out a box of screws and nuts, washers and so on, as soon as you are done, close the box and snap it shut. There's nothing worse than dropping a box of assorted screws and nuts. Okay, now we're going to put all the controls on the control board. Now we do it the way we always do. Eurorack is we put the components on, but we do not solder them yet. And all these pots are 100K. I always put the pots on first. Some people put the jacks on first. I put the pots on first because I find that jacks can make the board hop a little bit, and if the board hops a little bit, then that means you're going to pop the jacks off. Oh, look at that. Power connector is actually blocking that hole a little bit, on both sides. Oh, that's no good. Okay, I'm gonna have to, actually I don't have to get anything. I think I can shave this off with an X-Acto knife, but that's surprising. I have to cut some of the power connector plastic off around that jack lead. Okay, that's in well enough. Now I got to do the other one. Before I do any more surgery, I'll see if this already fits. Geez, how am I gonna take a look? That's gonna be a pain in the butt to solder too. Again, it's right up against that power connector. That's no good. Well, we'll see if we can get a good solder joint. But, let me move the light back out of the way. Now we'll set the switches in place too. And reseat all the jacks that came loose while I was fumbling around cutting. Now, these switches are going to be a pain in the butt. Now we put the front panel on before we solder anything. Get everything all aligned. And of course, again, the switches are the biggest pain because the switch handle is not directly vertical, so it doesn't drop straight on. In fact, I'm going to switch them all the same direction. This is often the hardest part of building a eurorack module, is getting the front panel over all the posts, sockets, switch handles, and so on. So that's that end. Now get this end. Now we'll get all the jacks seated. That's where we have pokey things to get everything lined up. Oops. Got the one end down and then let the other end slip. Okay, let's hang it. There we go. So that's the way it should all go. Now what I'm going to do is what I often do for making the front panel installation a little easier. Is I will solder one pin on a jack at this end without letting go of the front panel, of course. One jack on that end, and I'll do one leg of the top potentiometer. Soldered everything on so the panel's all well and tightly put together. I've gone over all the circuit points I can see on this side. They're all looking good. I'm going to do that on this one too while I'm in that mode. That doesn't look like it's soldered all that well. Now it's going to be good. And I use this little index card, so I'm only seeing one line of solder joints at a time, and I'm not overwhelming my brain to actually find errors. Okay, so that looks good. Oh, I'm sorry, the light. I moved the light while I was soldering. Now we will put all the panel nuts on. All the panel nuts are on. Okay, now we're going to tuck everything together like so. Make sure the pin header is positioned correctly and meets completely, and it does. Now we've got 4 little Phillips head screws. And now we'll put the power cable on. Now we do the final bit. The knobs and the parts bags. And again, the knobs are very simple, just press on, no set screws. And that's the build. That's the front, the side, the back, other side, top, and bottom. So we will be calibrating it all and putting it in the rack to test it out tomorrow, because I don't want to do it tonight. This kit, as you notice, has a lot of parts. It's a lot of soldering, but it's not hard soldering. It's not like it's surface mount or something like that. Just, it'll probably take you a couple of nights. So we'll put it in the rack tomorrow. Let's see how this thing sounds. So this is going to be, delay is all the way down and it sounds normal. Let me drop this down an octave. There's a little bit of ringing. Let me take this completely dry. And that took the ringing out. Bring the ringing back in. Let's turn delay up to about 1/4. Bring it up to 1/3. Two-thirds. That sounds pretty good. Let's go up even more. Well, that's certainly interesting. I'm going to go full wet on this. Now I'm going to dial in some feedback. Take the feedback back out. That feedback's really aggressive, isn't it? Let me pull down to 1/4 dry. That sounds like nice delay-ish. Very echoey. Now I'm going to try their crunch. So we throw in, let's see. Now we'll throw in some crunch. I'm going to try all three crushes on. And then do some feedback. Go full wet. Full everything and it turns itself off. Take some crushes off. Now they say that the crush can be triggered by CV gate also. Should be 3 volts. I'm not sure if I'm getting 3 volts out of my sequencer, but we'll give it a try. Turn the sequencer on to give it gate. I'm not getting anything, but again, I may not be giving it the right voltage. Sounds nice. There it goes. Hear that little oscillation in there? Let me turn the sequencer up even faster. Now you can really hear it. Let me go into another jack. That's without the sequencer on. Now I turn the sequencer on. You can hear it. You can hear the flutter in there. Gonna go to half wet. Take all the crush out. So that all sounds interesting. I'm going to do one more thing. I'm going to take the, where the heck am I? I'm going to take CV from the sequencer and plug the sequencer into the envelope generator. And now I'm going to slow this down too.
So I turned the sequencer off, and that was the remaining feedback until I pulled it back out. So that's the way it sounds. It's a good delay, and then it's got lots of crunchiness, lots of interesting things you can do here. For single shots, with the long delay, very wet, and lots of feedback, it's pretty interesting. But just even for a regular sequence, it's a good unit. Another good one from Befaco. And I hope you enjoyed the video.